Hi, how's it going? Welcome to Code with Z. Today's question is LeetCode number 31, next permutation. Now, I'll be honest with you, this is not my favorite problem in the list, but let's solve it together. And I want you to know that I'll explain and visualize everything in the coming slides. But for the sake of reading the question, let's see what the question is actually asking us for. So we gotta find the next permutation, right? But what is a permutation? Well, a permutation of an array of integers is an arrangement of its members into a sequence or linear order. Now, what does this even mean? Well, let's check our example here. As you can see, we were given this array that has 1, 2, 3 inside of it, and the following are all of the permutations. So the first permutation of this array is gonna be 1, 2, 3, and then 1, 3, 2. Now you might ask, how did we go from 1, 2, 3 to 1, 3, 2? Well, don't worry about it because I'll show you the algorithm in the slides. But these are all of the permutations of this array, as you can see. And if we take a look at it, we can actually see that they're kind of sorted from the smallest number to the biggest one. If you check, because here we go from 1, 2, 3, all the way to 3, 2, 1. And when we are given an array in this question, we don't have to find all of the permutations. We got to find the next one. Now, what does this mean? Well, for example, if we were given this permutation, the next permutation is going to be this one. And we can clearly see that in the examples. As you can see, we were given 1, 2, 3, and we've returned 1, 3, 2. Why? Because if we check, the next permutation to 1, 2, 3 is gonna be 1, 3, 2. Let's solve this together, and don't worry, I won't finish this video until I make sure you fully understand how to solve this problem once and for all. So as you can see, we're given this array here, and our array here is a little bit lengthier and larger compared to what we had in the examples. And I did this on purpose because this is gonna help us to see how the algorithm actually works when we visualize everything together. So we gotta go from this array to this array here. This is the next permutation, and as you can see, there are a bunch of differences. But how did we go from here to here? It doesn't make sense, right? So this is 1, 2, 3, 6, 5, 4, and this one is 1, 2, 4, 3, 5, 6. But we can't actually see a pattern, right? Well, to go from this to this, we have to follow a 4-step algorithm, and I'll show you right now. So the first step is that we have to locate the position of a number where it's followed by a number that's actually larger than itself. So we have to find the number that's followed by a number that's basically bigger than itself, and we're gonna do this from the right, not the left. All right, let's actually do this. We're gonna be like, so is 4 followed by a number that's bigger than itself? Well, 4 is literally not followed by anything. It's like literally the last element inside of our array, so no. Well, what about 5? Is 5 followed by a number that's actually bigger than itself? Well, no, 5 is followed by 4, and 4 is not greater than 5. So let's check the number prior to it. Is 6 followed by a number that's greater than itself? Well, no. 6 is followed by 5, and 5 is not greater than 6. What about 3? Is 3 followed by a number that's greater than itself? Well, yeah, actually, 3 is followed by 6, and 6 is greater than 3. Awesome. So we're gonna call this here pivot. So this position or this slot or this index is gonna be our pivot. In our second step, we're gonna be like, find the smallest number that's on the right side of our pivot and that's actually greater than the pivot itself. So we gotta find the smallest number that's on the right side of our pivot and that's greater than the pivot itself. Well, let's find it. Between 6, 5, and 4, 4 is the smallest number and 4 is greater than the pivot itself because our pivot index is gonna be pointing to this number here and that's 3, and 4 is greater than 3, so 4 is gonna be successor because we're gonna call this number here successor. Awesome, we've executed the second step perfectly as well. And then we're gonna go to the third step and we're gonna be like, swap the pivot with its successor. Let's do that. Let's swap these two like so. As you can see, they are swapped. And this was our third step. And then the final step is that we're gonna say, reverse the numbers following the pivot to achieve the smallest permutation. As you remember, in our permutations were sorted, right? And for finding the next permutation, we gotta make sure that we try to find the smallest permutation because they were sorted from the smallest one to the biggest one. So let's do that. We're gonna reverse all of the numbers following the pivot position, right? So this is the pivot position. So let's reverse these. This is 6, 5, 3. If we reverse it, it's gonna be 3, 5, 6. And this is it. If I drag this here and compare it with the previous slides that we had, as you can see, we went from this to this. And as you can see, they are identical, so our algorithm works perfectly. Now, let's visualize this together. So we had our array that we had in the beginning, and this is the first step that we saw in the previous slides, literally the same thing. And we gotta find the code version of this that's gonna help us to implement the first step. Well, let's think about it. We said we're gonna start from the right side, and we're gonna find a number that's followed by a number that's larger than itself. Well, because we're starting from the right side, we can actually define a variable called I, and that's going to be equal to nums.length minus 2, meaning I is gonna be equal to the index of one element to the last element. Why? Well, if you remember, when we checked 4, we had nothing to compare it with because we actually have to find a number that's followed by a number that's greater than itself. And if we check the last number, it's literally the last number, so nothing is followed by it, and it doesn't make sense to start from here. But if we start from one element to the last, we can actually compare it with the last element and check if it's actually followed by a number that's greater than itself. So the first value of I is gonna be nums.length minus 2, and that's gonna be the index of one element to the last inside of our array. And then we gotta find that position where a number is followed by a larger one. Well, if this was not the answer, we actually gonna check the number before it. We saw that in the previous slides. And if this was not followed by a number that was actually larger than itself, we check the number before it. So for doing this, we gotta have a loop that's gonna decrement I each time we don't find our answer. This is gonna be representing a loop, and inside of this loop, we only have I minus minus. And we wanna keep on looping as long as I is greater or equal to 0 and nums of I, meaning the number that I is pointing to, is greater or equal to the next number. So literally, if we don't have this, we want to decrement I. Our goal in this first step is that we need to find the position where a number is followed by a larger one. So here we say, keep on decrementing I if I is greater or equal to the number next to it. And this loop is gonna stop when we find the position where a number is followed by a larger one. After that, we're gonna say if I is greater or equal to 0, because we don't want I to be minus 1, for example. If I, for example, is 0, it's gonna be pointing to the first element inside of our array. But like if it's minus 1, that means it's pointing to nothing. So we don't want I to be actually less than 0. Inside of this if statement, we're gonna have to implement our second step, which was finding the smallest number to the right of our pivot, which is gonna be our I, that's larger than the pivot number. Meaning we gotta find the smallest number that's on the right side of our pivot, just like we saw in the previous slides, and it's larger than our pivot. For doing this, we're gonna have a j variable, and this j variable is gonna be equal to nums.length minus 1, so it's gonna be actually equal to the index of the last element inside of our array. And I'm currently just explaining the structure of the algorithm. I'll visualize everything in literally a minute, so don't worry. So we have to fulfill this second step. And if j was not actually pointing to that number in the beginning, we gotta keep on decrementing j to find that number. And that's why we have another loop that literally says keep on incrementing j as long as j is greater or equal to 0 and the number that our j variable is pointing to is smaller or equal to the number that our I variable is pointing to. This condition here is literally the opposite of the second step. So it means keep on looping as long as we find a number that fulfills this second step. When we finally get to that number that will actually fulfill the second step, we're gonna call a successor, and then we gotta fulfill the next step that will be swapping the pivot with its successor. And this is gonna be really simple. We literally swap I and j with j and I. This is literally a simple swap, and then at the end, we gotta reverse the numbers following the pivot to achieve the smallest permutation. So we're gonna reverse it, and this is it. Now let's visualize this code that we have here. So the first thing here is that I is equal to nums.length minus 2. Well, what's nums.length minus 2? Well, that's 4. Why? Because nums.length is gonna be 1, 2, 3, 4, 5, 6. So the length of nums, which is our array, is gonna be 6. 6 minus 2 is gonna be 4. So I is 4 and nums of I is gonna be this number. Why? Because this is the number with the index of 4. We're gonna enter this loop and we're gonna be like, keep on looping as long as I is greater or equal to 0. Well, I is 4, so this is true. And the number that I is pointing to, which is 5, is greater or equal to the number next to it. Well, 5 is greater than 4. So let's decrement I, and now I is gonna be 3, and it's gonna be pointing to this number because this is the number with the index of 3. Again, we're gonna check this condition. Is the number that I is pointing to, which is 6, greater or equal to the number next to it? Well, 6 is greater than 5, so yeah. All right, let's keep on decrementing I. Now I is 2, and it's gonna be pointing to this number here because this is the number with the index of 2. So is nums of I, which is 3, greater or equal to the number next to it? Well, this is 6. Nope. All right, then we're gonna break out of this loop, and now this is gonna be our pivot, and this step is done. Then we're gonna enter this if statement. We're gonna say, is I greater or equal to 0? Well, yeah, I is 2. So this is gonna be true, and we're gonna enter this if statement. Here we're gonna be like, j is gonna be equal to nums.length minus 1. Well, the length was 6 because 1, 2, 3, 4, 5, 6. So nums.length is gonna be 6 minus 1, that's gonna be 5. So j is gonna be equal to 5, and it's gonna be pointing to this number that we have here, because this is the number with the index of 5. Then we're gonna enter this loop, and we wanna keep this loop going as long as j is greater or equal to 0. Well, it is, because it's currently equal to 5, and 5 is greater or equal to 0. And we want nums of j, meaning 4, because this is the number that j is pointing to. So 4 being smaller or less than the number that I is pointing to. Well, 4 is not smaller or equal to the number that I is pointing to, which is 3. So this condition is gonna be false, and we're not gonna decrement j, and we're done with our second step, and we have our successor. In our third step, we have to swap the pivot with its successor. Well, let's do that. We're gonna say nums of I, which is 3, and nums of j, which is 4, should be equal to nums of j, which is 4, and nums of I, which is 3. Like so. Well, let's swap them. Awesome. And we're done with the third step, and then to the final step. In our final step, we're going to reverse the numbers following the pivot position to achieve the smallest permutation. Well, let's do that. This is our pivot position. All of these numbers here have to be reversed. We have to go from 6, 5, 3 to 3, 5, 6. Like so, 3, 5, 6. And this is gonna be our answer. Now, let's code this in the simplest way possible. Alright, so just like we saw in the slides, we're gonna first define our I variable, and this is gonna be equal to nums.length minus 2. And then below this, we're gonna have our loop that's gonna keep on decrementing I, and we're gonna say while I is greater or equal to 0, and nums of I is greater or equal to nums of I plus 1, meaning the number next to it, keep on decrementing I. And then below this, we're gonna have our if statement, just like we saw on the slides, and we're gonna say if I is greater or equal to 0, do the following. Here, we're gonna define j, and this is gonna be equal to nums.length minus 1, and then below this, we're gonna have the loop that's gonna decrement j. We're gonna say while j is greater or equal to 0, and nums of j is smaller or equal to nums of I, keep on decrementing j, so j minus minus. I'll scroll down a bit, and then after we've actually fulfilled the second step, we're gonna have the third step, and this is gonna be the swapping. So we're gonna say nums of I and nums of j should be actually nums of j and nums of I. So this is gonna do our swap, and it's gonna fulfill the third step. And then outside of our if statement, we're gonna have our reverse function. That's gonna take care of the reversing. We're gonna say function reverse, and this is gonna be a really simple function that's gonna take nums, start, and end. So it's gonna take the array, the start and the end of the area we wanna reverse. And here we're gonna say, this is gonna look really familiar, while start is smaller than end, do the following. And we're gonna say nums of start and nums of end should actually be nums end and nums start. And on each round, we wanna increment start and decrement end, like so. So now that we've defined it, let's call it. We're gonna say reverse our numbers array start from the I plus 1 index. So we want to reverse all of the numbers next to the pivot position, and we want to reverse everything till the very end. And this is gonna be our end variable. Now let me zoom out, and this is gonna be all of our code. Let's run it and see if this actually works. It would be really funny if it doesn't. Let's see, as you can see, 1, 2, 3, all 3 are passed. Now let's submit it. Drum roll, please. Let's see. Yep, accepted. Awesome. Thanks for watching. Don't forget to like and subscribe, and keep on coding.